Hello, good morning, students. Today's topic is desired C by I ratio, carrier to interference ratio from a normal case in an omnidirectional antenna system. The topic we are going to learn it. Once again, repeating desired C by I from a normal case in an omnidirectional antenna system. Topic number is 2.5 in the second unit of CMC subject. First of all, what is C by I? That we should learn. C by I stands for carrier. I stands for interference. C by I stands for carrier to interference ratio. That you should tell loudly. There no need to go and sit inside the memory. Next, carrier is the usual signal received from the base station. This is important point. Next, interference denoted with I. Interference is the unwanted signal coming from other cells using the same frequency. ఓకే, క్యారియర్ దేంతో డినోట్ చేస్తారు? క్యాపిటల్ సి. ఇంటర్ఫరెన్స్ దేంతో డినోట్ చేస్తారు? క్యాపిటల్ ఐ. ఫార్ములా ఫర్ సి బై ఐ ఈజ్ carrier signal strength divided by interference signal strength. That is the formula of C by I. Next, in this, I want to ask one question. Why C by I is very important? After knowing only, we will get interest in this subject. Why C by I is important? A mobile phone should receive a strong desired signal and minimum interference signal. Noise signal should be less. That's why C by I is important. That is the correct answer. Higher C by I gives better voice quality. Lower C by I gives noisy calls and also call drops and also slow data. That is the related to lower C by I value. Example, talking in a quiet classroom very easy than talking in the fish market, noisy market. Like that, we can give analogy. Next question I want to ask you. What is the desired C by I in a normal omnidirectional system? I'm asking you. Answer is, in a normal cellular system using omnidirectional antennas, the desired minimum C by I is about 18, 18 dB, 18 decibels ఉండాలి. ఎంత ఉండాలండి? Normal minimum C by I is about 18 dB. That you should memorize. This 18 dB value provides good voice quality, reliable communication, acceptable interference level. Okay, that is the technical point. Logic is there in that. Next question is, what does 18 dB mean? 18 dB అంటే ఏంటి? Okay, 18 dB does not mean 18 times stronger. 18 times stronger. It means 18 dB means carrier signal is approximately 63 times stronger than interference signal. Like that, you should load this technical point in your memory. If you want example, I can give. If interference power is 1 unit, the carrier power should be about 63 units. Like that, you should answer in the Viva OC. Next point. Classroom example I want to give here. Imagine a teacher is teaching in the classroom. Here, what I want to tell, teacher's voice should be equal to carrier signal. Next, students talking should be equal to interference. Here, what I would like to tell is, if the teacher's voice is much louder than students' voice, that is disturbance, everyone can hear clearly. Clearly. So always teacher should talk loudly. Then students disturbance. This is similar to having high C by I ratio value. This is very good example I have given. Next point, mobile networking example. For example, suppose your phone receives desired signal which is equal to 63 units, interference signal which is equal to 1 unit, then C by I is approximately equal to 18 dB. 18 dB. Like this it is calculated. C by I ratio. Result. What is the result if you get 18 dB? Clear voice, stable connection, better quality. That is the benefit. That is the merit. Next point. Why does interference occur? ఎందుకు డిస్టర్బెన్స్ వస్తుంది? Interference mainly occurs because the same frequency is reused in different cells. That is the technical point. If two TW2 co-channel cells are too close, that means distance is less, then what will happen? Their two signals will overlap. That is the problem. Voice quality will decrease. That is the problem. Data speed also affected. Data speed will become low. That is the problem. Next point. How can engineers improve C by I value? How they can balance it? Engineers improve C by increasing the distance between co-channel cells. Number one. Number two, choosing a larger frequency reuse cluster size. That is a third technique. Third, the second technique. Third technique is using sector antennas instead of omnidirectional antennas. That is third balancing technique. Fourth one is careful frequency planning. By these four techniques, engineers will balance. Next, disadvantage of increasing C by I. Although increasing C by I improves communication quality, it also has a drawback. What is the drawback? If co-channel cells are kept too far apart, what will happen? More frequencies are needed. Frequency reuse decreases. System capacity become lower. Therefore, engineers always maintain a balancing technique between good quality and efficient spectrum utilization. That is the logic. You should remember, my dear CMC students. Bye.